Alright, well, this isn't exactly how I had planned on working on section 9.2, but here we go. Section 9.2 is on graphs of polar equations. And for our first example here, we're going to graph r equals 3 sine of 2 theta. The graphing in polar looks, pretty similar to graphing on the xy coordinate plane. And we're going to start here by graphing an equation by hand, although I'm not going to expect you to do a lot of graphing by hand when we're working in polar. But I do want you to get an idea of why the graphs look like the way they do. So, when we started graphing x and y coordinates, way back when, you started by plotting points, and we'll do the same thing in polar. So you have a table here, and I've given you some values to use for theta. I counted by increments of 30 degrees, just so we get a good graph that spans around the whole polar coordinate plane. And I'm going to do a few just to get you started, then we'll stop the video and have you fill in the rest of the table, plot those points, and see what the graph of r equals 3 sine 2 theta looks like. So the first thing we're going to do is find the exact value of r. Okay, when we do that by taking the values of theta that are in the table there, and again, I just chose those to go by increments of 30, so that we could get all the way around every quadrant along that graph. So we're going to substitute that into the equation where theta is. So r equals 3 sine 2 times 0 degrees. Now if we're wanting an exact value, then we're probably thinking about what we know about trig here. So the sine of 0 degrees, because 2 times 0 degrees is 0 degrees. The sine of 0 is 0. 0 times 3 is 0. So in this case, the exact value of r is 0. The approximate value of r, there really isn't one, but it's 0. So as an ordered pair, that would be the ordered pair 0, 0 degrees. We're going to plot that point then on our polar plane, which I don't have one here, but that would be at the pole, like at the origin, but in polar coordinates we call it the pole. Alright, so our next spot, our next angle we're going to put a point at is at 30 degrees. So that's along, one of the lines jutting out there. I think it's, on your graph, I think we're counting in 15-degree increments, so it's the second one up. And we got to figure out how far out we need to go make that point, so we need to find our r. So r equals 3 times the sine of 2 times 30 degrees. Okay, so what's that exact value? 2 times 30 degrees is 60 degrees. The sine of 60 degrees is root 3 over 2. Root 3 over 2 times 3 is 3 root 3 over 2. So the approximate value, we're going to use our calculator to do that. The approximate value for r there is, I believe, 2.598. So the ordered pair here is 2.598, 30 degrees. Now again, I don't have the polar graph paper here, but you want to go on the 30-degree line, you want to go out about 2.5 in terms of the radius. That's going to be pretty small. Okay, we'll do the same thing for 60 degrees here. So r equals 3 times the sine of 2 times 60 degrees. 2 times 60 degrees is 120 degrees, and the reference angle for that would be a 60-degree angle. Since it's in the second quadrant, sine will be positive, and since it's a 60-degree reference angle, the value is root 3 over 2. Then 3 times that is 3 root 3 over 2. So its approximate value is also 2.598, and so its point should go at 2.598, same radius, but now at 60 degrees. So I want you to take some time here and work through filling out the rest of that table, plotting those points. I'm going to pause the video, and then I want you guys to compare it to what I show up here in the next video.